All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna be continuing learning about Git, relearning. I'm I'm usually not sure what word to use there because I am kind of relearning stuff that I already learned before, but at the same time, I'm also learning new stuff that I didn't know before. So I'm always kind of like torn between whether I should say learning or relearning. But yeah, okay. We're gonna continue relearning Git. This time through Git UI. This is part two of the session, which started yesterday. Yeah, it's basically a continuation of what we were doing yesterday. I figured I'll just do another stream of Git UI, and hopefully, if we finish, so um, there's five chapters. We've gone through chapters one, two, and three. We looked at simple stuff like creating the repo and and doing commits, making changes to the working directory, and then making commits, and then viewing commits, and also undoing commits. And now we are going to be looking into um, branching. I think remotes comes next because the push and pull thing, that's more of a remotes thing as far as as far as I know. Um, as far as I understand, the push and pull thing is it's more connected to remotes. Let me just take a look at this. So I have the Gemini conversation open on another screen, and I'm just reading that out. So chapter 4, branching out, creating, merging, and deleting branches. By the way, real quick, I want to show you guys something interesting that I found yesterday. It's this tool called Siri. So I was looking for ways to generate commit graphs of repos. Commit graphs basically show you various activities that have taken place within this repo. I don't know about all activities, but it shows you a fair bit of info. It definitely shows you the commits that have happened. It also shows you the branches. Um, I don't remember if I have one of the more complex repos here, but like once we start going into, I mean, we are going to be doing the branching thing right now, so I can show you guys. Right now, I just want to show you the tool. This tool is specifically meant for generating a commit graph and being able to explore the entire repo's history through this commit graph. I was looking for tools that could do this kind of thing because I kind of like being able to see that visual representation um, of the repo's history, and I wasn't really satisfied with what Git provides. For example, let me show you guys. What was it? I think Git log. Um, I can't remember all of the stuff. There was it all? Is all a thing? Well, okay, all and then one line and then there was something called decorate. I don't remember what that does. Then there was graph, and then there was one more thing that I'm missing. But yeah, I think this is it. So it shows you um, a very simple representation of a commit graph in whatever way it can do it best, considering that, all this is being done within the terminal itself. Considering that it does its best to generate a graph. And I'm not entirely sure about this part. I need to do more research on this. Maybe we can actually do this on stream as well. But I think the output that this command generates, or like you can probably give it certain arguments to generate a certain kind of output that you can then feed into the GraphViz library to generate a graph for you. So I'm guessing it's probably gonna generate something that can be converted to the dot language, or maybe this command itself generates um, dot dot language representation of the graph. I don't know. We're gonna have to um, test that out later. But like even in that situation, it's not gonna be like a navigatable or navigable. I'm not sure what the right word is there, but it's not going to be a graph that you can actually interactively navigate. It's not something that you can interact with. It's at best, it's probably going to be an image that you can look at. And I'm going to be honest, initially, I was looking for just an image. I was looking for just something that can generate just an image so I can get some sort of visual representation. However, once I came across this tool, and this is also thanks to Gemini, I got this idea. This is a tool made specifically for exploring commit graphs of repos within the terminal. So it uses the terminal's graphics protocol, uh, and fortunately, it explicitly supports the Kitty terminal's graphics protocol, which that's the terminal that I'm using. Fortunately, it does support this terminal's graphics protocol, and so I'm able to make use of it. So this is what it looks like. You can cd into your repo directory and then launch the app, and this is the output that you get. So you can then go into any commit and look at the details of the commit. There's also a thing of diffing, which is this. I need to learn how to read the diffs, because this is a specific format that gets used even outside of this context. In general, when you do diffing, it does use something similar to this. I need to learn how to read this and figure out exactly what it is that I'm reading and how to interpret that information. But yeah, I'm excited. I found out about this program and I'm going to be using this quite a bit. I'm definitely going to be using this quite a bit. I wonder if there's a way that we can generate something relating to the ref log of the of the repo, because this is more log related. Git also has a ref log. No, Git. Yeah. So reflog gives you slightly different information than log. One of the many things that reflog is good for, and I found that's actually how I discovered the reflog command. It shows you at different points where the head was pointing. So you can then find out at what point it was in, let's say, a detached head state, or at what point it was pointing towards branch A or branch B or main branch or whatever. Okay, all right. So we are gonna get back to, was it here? Or maybe it was here. Yeah, it was this. So we're gonna get back to this. I'm gonna do this commit. What was this? Updated some file o1.txt, and we commit that, and then this is what our commit graph looks like, or our list of commits looks like. Also, I would definitely like to be able to find out how we can figure out which branch we are currently on, specifically through Git UI. How do we find that out? Because so far the only thing that I have is this. When you open up this branches window, there's an asterisk next to the name of the branch that's currently that the head is currently pointing to. I wonder if there's some other way, because when I look at the UI here, it doesn't really show which branch is currently being. Oh, actually, it does. No, hold on. I just realized this. Wait. Um, Here in the staged changes panel, in the top right, it mentions master. I just noticed that. Okay, cool, great. That that definitely helps. So that problem is solved now, I guess. Okay, so let's get into branching. So, chapter 4, branching out, creating, merging, and deleting branches. Branches are the key to Git's collaborative power. Think of a branch as a separate parallel line of development. They allow you to work on a new feature or fix a bug without affecting the main project. Okay? When you work when your work is complete, you can safely merge your changes back into the main branch. Okay. In Git, the default branch is usually called master or main. It's the primary line of development. You can create new branches off of main, do your work there, and then merge them back. Branching and merging in Git UI. Git UI makes branch management incredibly intuitive. You can access the branch management panel by pressing tab to cycle through the different views until you see the list of. Okay, so it doesn't really know what the UI is like, or maybe it doesn't have a more latest representation. Either way, it's fine. To access the branches, we can press the B key, and that brings up the list of branches. Not just local branches, apparently even remote branches, which we're going to be getting into later on. Okay, cool. Right. So you can create a new branch. You can check out a selected branch. You can merge a selected branch into your currently checked out branch. Okay. Yeah, okay. This specific thing, I feel like I need to get a better understanding of what's happening here. I need to get a better understanding of what is merging into what exactly. Like, are we merging? Like, for example, let's say we have the main branch, and then we have branch A, and main branch is it's got its development going on, and at some point I add like a new feature to branch A, and branch A is ahead of main branch in terms of commits, and then I want to merge branch A into main. Is there a difference between merging branch A into main and merging main into branch A? Is there a chance that I could accidentally do it in the wrong order? If that does actually happen, then is there like a chance I could actually, do it in the wrong order? Because I don't think merging into main is the only way that you could merge. I'm guessing that you can also merge one branch into another branch. Well, main is also a branch, but I'm guessing you can probably merge, let's say, words. Hold on. I'm guessing you can probably merge, let's say, branch A into branch B, and then you can merge branch B into the main branch if you want. Okay, cool. Let's create a branch. So we have jumped to the exercise portion of this chapter. The branching workflow. Let's simulate a common workflow. You want to add a new feature, so you'll create a new branch, work on it, and then merge it back. Create a new branch. Make sure you're on the main branch. In Git UI, press Tab until you see okay, all right, and then press C to create a new branch. Name it Add New Feature and press Enter. The main branch is now your source, and the new branch is your destination. I didn't get that. The main branch is the source, and the new branch is a destination. Yeah, I didn't get that. Okay, switching to the new branch. Git UI will now ask you if you want to check out the new branch. Select yes and press enter. Okay, so from what I have understood, checking out a branch or even a commit is basically telling Git to change the position where head is currently pointing. That's what I've understood out of this whole checkout thing. I can confirm that later on. Yeah, actually, I did. I did confirm it in a different Gemini conversation that I was having. It mentioned because I was trying to figure out the whole idea behind detached head and checkout. And give me a second, my voice is getting all weird because I think it's because I haven't drank water. Give me a second. Let me hydrate. Okay. I forgot what I was saying. I was talking about how I had. Wait, give me a second. Yeah, I was talking about how I was having a conversation with Gemini about the whole idea behind detached head and head and checkout and certain other terms. I was just trying to get a proper understanding of what these terms are and how they are related. Because usually people don't say like switching to a new branch; they say check out so and so branch. But the idea, like it's understood that you're checking out that branch. In fact, I think yeah, they did with one of the versions of Git. At some point, they added a Git switch method just to make it more explicit that yes, you are switching to so and so branch. Hold on, let me see if that's mentioned here. uh Explain the part about creating a new branch from it. Okay, okay. Yeah, oh, okay, wait. I think it's here maybe. So there's git branch, then there's git checkout, and then there's git switch. Um just a second. I'm trying to get the right information here. Because it did mention that with one of the Git versions, they introduced Git switch to to make it less ambiguous because the Git checkout feature apparently does multiple things, not just switching to a different branch. Actually, I think the multiple things there might have been One of the multiple things might have been the fact that it doesn't just switch to branches, it also um, points the head to a specific commit. So you're not limited to just pointing the head to a branch. That's the whole idea. When you're switching, quote unquote, switching to a branch, you're pointing, you're telling the head to point towards one of those named branches, but you can also tell the head to point towards a commit, which is not a named branch. And in that case, it enters, I don't know what I should say enters. Like, does the repo enter, or does the head? I guess the head. The head enters a detached head state where the head is pointing towards a specific commit. It's not pointing towards any named branch. Okay, okay. Let's continue with this thing. Yeah, we are supposed to create a new branch which is named add new feature. Okay, so let's create a new branch. Uh, okay, add new feature. All right, you hit enter and it automatically switches to that branch. We can also check out the master branch. We can go back to add new feature. Great, awesome. So switch to the new branch. Git UI will now ask if you want to check out the new branch. Select yes and press enter. Okay, you'll see the branch name at the top of the interface change from so and so to so and so. Okay, make changes on the new branch. In your terminal, add some content to a new file called feature.txt. This is my new feature. Okay, all right. So let's do that. Let's create a new file here, feature.txt. Oh, okay. This is my new feature. So we save this and we go back here. Now we have our unstaged change. It's a single change. Okay. Right. Now stage the change and commit this file with the message feat add new feature file. You now you have now made a commit that only exists on the add new feature branch. Okay, let's do that. So come here, do this, feat add new feat. Wait, what is it? Feature file. Okay, that's done. Then merge changes back to main. Press tab and go back to the branches panel. Select the main branch and press enter to switch back to it. Okay, so branches, do this, and actually, real quick, right. So here it mentions which branch this commit was made in, which is great. And in files, we can see feature.txt. Great. Now, if I switch back here, we don't have feature.txt anymore because this is a different snapshot, or this snapshot doesn't contain that file. Okay, so you'll see that feature.txt, you'll see that the feature.txt file is no longer in your working directory. This is because it doesn't exist on the main branch yet. Sorry, zoned out. Okay, this is because it doesn't exist on the main branch yet. With the main branch checked out, go back to branches and select the add new feature branch and press M. Git UI will ask for confirmation. So, okay, I need to kind of develop this pattern because, okay, here's where my confusion comes in, right? And this is what I was talking about previously. What, like, are we merging main the into the feature branch, or are we merging the feature branch into main? Like, I need to no, well, I understand that the idea is to merge the feature branch into main, but I need to know whether the opposite is possible and how do I avoid doing the opposite. So, okay, with with the main branch checked out, we go to add new feature, and then where's the merge option? Let's look at more merge. Okay, M, right. I need to understand this lower part here where it says pending merge commits so and so. Real quick, what is the hash of that commit? How do I quit this commit thing? No, no, no. Don't undo the last commit. How do I quit? What if I unstage? There was a way that I'd done this before. It's definitely not Q, is it? It's not Q. And it's still saying pending merge. That's interesting. Okay. Now, how do I get rid of this thing that I've started? I need to know this because just in case if I accidentally do the merge thing in the future, I need to know how to. Okay, what if we do this and we just check this out? Nah, there's a merge process going on here. Okay, let's unstage. If we unstage, abort merge, there we go. Wait, does the abort merge option come? Oh, there it is. Yeah, that's what I was looking for. Abort merge. This will revert all the uncommitted changes. Are you sure? Yes. Okay, cool. So this is our commit in the add new feature branch. Great. Awesome. So now we'll check out the master branch and then come here and hit M, and that's what it's merging. Okay. I need to get an understanding of like what exactly is going on with this, like when there's a merge. Also, real quick, now that we have a separate branch, which we haven't merged yet, let's go take a look at what the commit graph looks like. Oh shit, you guys can't see it because there's certain graphics elements that don't show up on. How do I show it? I wanna show you guys the thing on the left side. There's something that shows up on the left side, but then that's not showing up in Tmux. Um, I don't know if it's specifically a Tmux issue or if it's just not performing well over SSH or if there's some other issue. Hold on. Let me try something here. Okay. Actually, I'm curious about something. So let me do this. Oh, okay. That's fine. What was I going to do? Yeah, let's bring that back. Okay, hopefully I'm able to show it to you guys through this screen. So we will cd into scratch stuff and what's the name of the repo? Is it some repo? No. What is, just a second. I don't remember what the thing is called. Some underscore. Okay, and then we do this. So this is what I was trying to show you guys. The thing on the left side, you can see like the commit lines and stuff. But what's interesting is that it's not showing like diverging lines. I wonder why that is. Yeah, hold on. Hold on. Let's see here. What was I doing? Oh yeah, we haven't merged the branch yet, have we? We are yet to do that. We are in the process of doing that here. So we commit, merge branch, add new feature. Um, okay, merged. Okay, now let's see what oh, there it is. That's that's what I was looking for. So you can see how it creates like a different branch and then it notes down the commit of that branch as well. And then later on it merges into the main branch and it creates a commit out of that merge. Let's see what details it gives. It says merging. Okay. All right. Yeah, I need to get a better understanding of what exactly is happening internally during this whole merge process. Okay, where was I? Right, let's check our files. So we now have feature.txt within our main branch, and within branches we still have that old branch in the list, but it's now merged in. What if we do this? What if we go back here? Actually, yeah, if we oh, sorry about that. Yeah, if if we go back, then we are going one step back in terms of commits. Yeah, we are going one step back because now the master branch is one step ahead, right? Okay, cool. Then clean up the branch. Since the add new feature branch has been successfully merged, you can now delete it to keep your branch list clean. In the branches panel, select add new feature and then press D, confirm the deletion, and the branch is now gone. Okay, let's do that. So we come here and there is a delete option, which is Shift D, confirm. Okay, okay, hold up. Oh, by the way, yeah, there's another fun thing about Siri. What was it? Tab, I think. Yeah. So with Tab, you can look at a bunch of like extra information as well, stuff like branches and remotes and tags and even stashes. That's interesting. Okay. So yeah, let's delete that. We are done with that now. Cool. So, you've just completed a fundamental Git workflow for managing features and fixes. Branching is at the heart of collaborative development and is a key skill to master. Ready to connect your local repository to a remote one and collaborate with others? Not yet. Hold on. Not not just yet. Not yet. I want to understand what exactly is happening during the merge and how this whole thing works. I've been told that head points to no. I've been told that when a certain branch is currently active, head points to the latest commit of that branch. I also want to understand the difference between merging um, add new feature branch into main branch and merging main branch into add new feature branch, because it seems like if I mix up the two, it could cause issues. So what exactly is happening when a branch is created and switched to and committed to, um, hold on, and finally merged? Okay, so Gemini is going to give me an explanation about this. All right, that's an excellent question, and it's where the real power and complexity of Git comes to light. Okay, understanding these underlying mechanics is crucial for using Git effectively. The head pointer, you're absolutely right. The head pointer is a reference that always points to the latest commit of the current branch. It's how Git knows what you're currently looking at in your working directory. Think of it as your project's current position marker. When you switch branches or make a new commit, Git moves head to reflect your new position. The branching lifecycle in detail. Let's walk through the exact steps of what happens under the hood. Branch creation. When you create a new branch from main, Git does one simple thing. It creates a new pointer that it creates a new pointer that points to the exact same commit that main is currently pointing to. That's it. Hold on. It creates a new pointer that points to the exact same commit that main is currently pointing to. Oh yeah, because branch names are also pointers. Okay. Okay. That's it. It's an incredibly cheap and fast operation. Head does not move. The only change is that a new pointer exists. Conceptual diagram is so and so. Okay, all right. Here, both main and add new feature pointers point to the same latest commit. All right. Branch switching. Git checkout. When you switch from main to add new feature, two things happen. Git moves the head pointer to point to the add new feature pointer, and this tells Git that your current position is now on that branch. Wait, back up. Git moves the head pointer. Wait, give me a second. Okay. All right. So, where was I? Yeah. Git moves the head pointer to point to the add new feature pointer. Okay, back up. Let's go back to what exactly head is. The head pointer is a reference that always points to the last commit of the current branch. It's how Git knows what you're currently looking at in your working directory. Okay. Think of it as your project's current position marker. When you switch branches or make a new commit, Git moves head to reflect your new position. Okay. All right. So here Git moves the head pointer to point to the add new feature pointer. This tells Git that your current position is now on that branch. This tells Git that your current position is now on that branch. Okay. All right. Sorry, zoned out for a bit. Okay. Git then updates your working directory to match the files of the commit that add new feature is pointing to. In our example, since both branches point, yeah, currently there haven't been any new commits on the branch. Okay. In our example, since both branches point to the same commit, there's no visible change to your files yet. Committing on a new branch. Okay. This is where the branches diverge. When you create a new commit on add new feature, a new commit object is created and two pointers are updated. The add new feature pointer moves forward to point to C4, which is the next commit, and the head pointer, which is attached to add new feature, also moves to point to C4. The main branch pointer does not move. It stays pointing at C3. Okay, so it's given a conceptual diagram here, but I'm not really able to understand the conceptual diagram that it gave, but that's fine. Okay. The difference between merge directions. This is a common point of confusion. The key difference is which branch history receives the new merge commit. Merging add new feature into main. This is the standard practice. You are on the main branch. You tell Git to merge the changes from add new feature into main. Git creates a new merge commit on the main branch. This new commit has two parents, the last commit from main and the last commit from add new feature. The entire history of add new feature is now integrated into main. This result is no, this results in a clean, linear looking history on your main branch. Okay, all right. Merging main. Merging main into add new feature. This is often called keeping a feature branch up to date. Oh, I just realized something. I was looking at this the wrong way because when you merge the main branch, when you merge add new feature branch into the main branch, you're not deleting add new feature branch yet. You're just merging it into main branch. So you've made a change in main branch. You haven't made a change in add new feature branch. So I wonder if you can still commit to add new feature branch, because here it mentions that if we are talking about merging main into add new feature branch instead, then this is often called keeping a feature branch up to date. You are on the add new feature branch. You tell Git to merge the changes from main into your current branch. Git creates a new merge commit. I think this is a way to up. Oh yeah, there's that. Now it makes sense. Yeah, this is a way to keep the branch up to date in case if it's way too many commits ahead of way too many commits ahead of. Hold on. If it's way too many, okay, this is a way of keeping that other branch up to date, in case if the main branch has gone way too many commits ahead of the uh, other branch. So then you can like merge it and you can have all of the new stuff from main, and then you can continue to work. Though I'd imagine doing that, like you would need to be careful because you would risk merge conflicts if you if you know if let's say the same files are being worked on in both the branches, then there might be merge conflicts. Though, I mean, to be fair, that could also happen in like the regular branching method, not necessarily just in, this keeping the branch up to date method. Okay, Git creates a new merge commit on the add new feature. I feel like I need to note this down for experimentation. Um, Branching. Create branch. Create branch A. Do commits. Switch to main branch. Do a couple of commits. Then switch to branch A and merge main into branch A to keep branch A up to date. Yeah, this would be interesting to see because I feel like I wanna test this out. Hold on. I also want to see um what the commit graph is gonna look like. Okay, so let's create another branch. Let's just call it branch A. Okay, branch A. And we've switched to this branch. Now here we can, I guess we can close this. No, wait, you know what? Feature. This is a change made from branch A. All right. Now here's what we're gonna do. We are trying to wait. Hold up. So let's stage and commit this. Updated. What was it called? Feature.txt. Commit that. Now let's switch to the master branch. Okay. Actually, okay. Yeah. So switch to the master branch and what was I going to do? Oh, yeah. So now that we've switched to the master branch, we have this, right? So I'm going to leave this line empty because we have something on that line. And then I'm going to add this line. this is a change done from main branch. Okay, so now we have this change. Let's commit.